When a severe medical emergency happens far from a major hospital, every mile of distance represents a direct drain on the patient's physiological reserves. Ground transport is the immediate response, but it operates within rigid physical limits. Traffic, speed caps, and geography often create a gap that a highway journey simply cannot bridge in time. Attempting to solve this through multimodal transport, shuffling a fragile patient from an ambulance to a helicopter to a commercial jet, introduces new risks. Each handover involves physical manipulation and exposure that can destabilize a trauma victim. Even large private jets have a major constraint. They require long, paved runways. In remote areas, the drive to the nearest primary airport can take hours, defeating the purpose of a fast flight. In a crisis, the outcome is dictated by the variables of time, infrastructure, and the friction of multi-step transfers. Total Aviation Services views medical transport as a logistical engineering problem. Their primary tool is the Fairchild-Swearington Metroliner 23, an aircraft designed to function as a dedicated airborne medical system. This math illustrates how the Metroliner compresses distance. While the inner ring shows the limit of an ambulance over 60 minutes, the Metroliner reaches out at 280 knots, covering a massive geographic area in the same window. Note the heavy-duty landing gear and high-performance turboprops. This configuration allows the aircraft to utilize short, unpaved local runways that larger jets cannot touch. By landing at these secondary airstrips, the medical team avoids the delay of major hubs. They fly directly to the patient's location, cutting out the dangerous middle steps of the journey. The act of boarding an aircraft is often a point of failure for critical patients. Standard narrow doors require crews to tip, twist, or lift a heavy stretcher, which can cause sudden drops in blood pressure or dislodge life support lines. The Metroliner 23 utilizes a wide cargo door for linear entry. Stretchers and incubators slide straight into the cabin, remaining perfectly level throughout the process. This structural design ensures the boarding process is a smooth, low-risk continuation of the clinical care started on the ground. At high altitudes, the drop in atmospheric pressure causes internal gases to expand, a physical reality that can be lethal for a patient with internal injuries or respiratory trauma. Managing these decompression complications, or dysbarisms, requires the aircraft to strictly simulate a ground-level environment. This cross-section shows the Metroliner's pressure management system at work. As external pressure falls away during the climb, the internal cabin pressure remains locked at sea-level conditions. Inside this stable environment, the cabin dimensions provide enough space for the medical team to stand and manage complex life support equipment while in the air. The Metroliner functions as a mobile intensive care unit, providing continuous, high-level treatment throughout the duration of the flight. Even the most advanced machinery relies on a synchronized human element to succeed. This integration is the core of the Total Aviation Services model. It is not a flight, it is a complete operational solution. Aviation logistics, specialized machinery, and highly trained medical personnel are unified into a single, cohesive team designed for immediate response. For critical care logistics where every minute impacts the medical outcome, coordinate with Total Aviation Services for immediate deployment. Stripping away the variables of time, access, and environment aligns the logistics with the medicine. It preserves the window of opportunity for survival.